Welcome back, another exciting day. Today I'm cutting out all the bits for both kits from 10mm thick acrylic, and I realised several things which are worth mentioning. The first is to cut everything in one go, because I at one stage decided that it would be better to reduce expansion and compression, all sorts of other effects, distortion, to cut all the middles out one after another, then move on and cut the next bit out, and then the next bit, and then the next bit. Whereas actually I found it's far better to cut out the middles and the outsides one not straight after another, because the plastic is then just heated up once and then cools down once and doesn't distort. The second thing that I found really important was resting 10mm acrylic on white card. This is any old bit of white card. For two reasons. One is that any leftover laser, when it's set to go so slowly, I think it's 1.4mm a second at 40% power, if it's just resting on the honeycomb stuff, all the remaining laser shoots through all the hills and tries to set fire to anything underneath, including the paint that was originally on the inside of the tray. Whereas sitting it on white card is fantastic. It basically absorbs the remaining laser power and bounces some of it back, giving you a beautifully radiused edge all round. So the bottom half of all these bits, the edges will all be radius slightly. Thank you very much. In other developments, we have vertical barometric prognosticators. I went round the side and retrieved these two supports, which are really handy, because I'm now starting to need to work on the front and the back. I'm going to put that encoder thing in there, so that's very exciting. All the 10mm bits cut out, and I can't remember what, well, any of them do really. I'm figuring it out very slowly as I go, trying to work out what all these little spaces and things are for. Just going to use one of them actually, which I think is that one. That is going to need to fill the gap between the copper pipe and the clock body. But I have a jig, as always. Here's the jig. It's a disc, the same profile as the clock, and even got it lined up, I've marked on, and I can see that's absolutely perfect. So I can sand the profile that I require on there, and I can line it all up with another part of the jig. Lots of jiggly boos, excellent. So I'm going to clamp that down, get it all lined up, and I'll get back to you. Talking of sticking things together, which I wasn't, I've remembered how I'm going to support this on the end of that copper pipe to sand it. I think glue that bit on. That also, the outside of this is just the right size to put one of the nuts, one of those on to hide the join, so to speak, which is how I did that one there, where the copper just goes into the board. Right, and then making the adapters, the linkages that will link the end of that to the switch, which is buried somewhere down there. I've just done that math, and 13.8mm is the gap between the end of that and the end of the switch. And now I've found all these little bits of 10mm stuff, and I believe you have a circular one that fits over that, then you have a solid one, which is the link that sort of makes it up to about 13mm, 10, and then you have the funny shaped one with a flat on it that goes on the switch, and you glue those three together, not like that. I'll do that twice, because I'm pretty sure that's how it works. It's lovely when these old things, memories come not flooding back, dripping back. It's great. Hopefully that will work then, and I know that they're all small enough to fit inside a piece of 15mm copper. There we are. I've lined this up. Pillar drills are just so incredible, they really are. They're so versatile. So I've lined that up with that line that I've drawn on there. This is then going to spin round. I've taped that onto the end of that, and I'm going to slowly, slowly sand that. Let's try it and see. It's not twisting it around. I didn't put this high enough. It hasn't done the bottom. Let's just without twisting it too much. I'm an idiot. Just down the bottom bit. That's it. And then, oh, an idiot. Right. Yeah, just enough. Yeah. There you go. Perfect. So that will now screw onto the side of the clock body. I'll do the other one. Oh. Nah, super glue to the rescue. Just lifted that away, put some super glue on the end of the rubber, up the plastic thing, and then just slowly slid it back together. That'll hold it at least while I can then line up and drill a hole to put a screw through it. Right, I think I need this bit cut out. Oh, the reason why it all looks a bit strange with the overall gear, all these bits cut out, is because you don't need them. Two reasons. One, it'd be a waste of plastic because it's not seen. Secondly, it makes it a lot lighter. Thirdly, even, it saves plastic because I can cut all the bits out of this unseen part. Makes it lighter for the motor to turn as well. These three are for the clamping into the jaws of the chuck on the lathe. It's a cunning plan. Right, let's, oh, I've lost it again now. Show you what, oh, here we are. Show you what this bit's. It's just so nice, I can't tell you. To finally have got back to where I was when I first got the laser cutter, being able to cut really fine things, just simply because I got too clever and changing all the different bits and pieces, and just absolutely ridiculous, stupid. Whereas just setting it to cut once on a bit of card, it does it perfectly. Here's the bit. What's it for? Well, I haven't done this one yet. Look at that. It just, oh, the joy. Just pushes on firmly, and then that pushes on firmly over that, and I'm going to glue it together as always with wonderful super glue. And in fact, that's what I'm using to glue all the plumbing together for all the machines, actually, because it just makes it so enjoyable. There's really no point in getting a blowtorch out and solder and flux and all that. It's lovely because you can line it all up, just drip some super glue in the end of the fitting, and then just push it in or twist it or angle a little bit before it sets, and it really does make an extremely strong joint. Now I can put the tap together. I've got all these tightened down temporarily, so there we are. You can see glued that onto the spiral bit, which sticks really well. I'm not going to glue that because obviously you may want to get it apart to repair or replace, and it's very important not to end up designing stuff that you can never get into again. Let's put that on there, tighten that. Yep, that's really nice, and the slight little bit of slack there is really good because it means that the switch positively clicks even if this is a bit stiff. Now to get some illumination sorted out for the power on indicator. And here we have it. A flickering amber LED on a little bit of Vera board with a resistor, 220 ohm resistor, to run it from 5 volts. You can see actually it projects quite a nice beam, and I discovered that for the power indicator anyway, there's, if you think about it, I've got the lens at the front, I've got an opaque white disc glued in there, and then at the back there's an oval, and I'm going to fix that there because I found that projecting it onto the white disc that's inside looks really nice through the lens, and I'm going to glue that on. In the past I have actually used a screw, but I think, you know, if anything goes wrong with this, I'll just prise it off. Although all the ones that I've ever installed or created all continue to work, at least this bit does, so I will, well, all of them do actually, I will glue this in place. Oh, and the reason I've connected it up just to check it works is it's always a little bit doubtful if you solder too close to the actual LED itself. If too much heat gets on the wires, they can melt and then break the connection inside. The other amazing thing about these flickering LEDs is they've got a little integrated circuit in them, on them, teensy little black speck that you can see if you look closely, and that's got a load of random numbers stored in it. and that tells the flame as it cycles through, switching on, switching off, and the brightness and other things. Absolutely incredible. I remember seeing a YouTube video, and I can't remember the address or whatever information on it, about someone who'd actually cut one open ever so carefully and analysed what it was actually doing. It's incredible. So that's glued on. Let's have a look at the other side. And there we have it. Beautiful. The amazingly funny thing about electronics is to try and get something irregular is really difficult. It involves things like storing lists of random numbers, because it's also reliable and predictable, or should be at least. Interesting. Now the next thing is to make the bearing supports that guide the Scotch yoke backwards and forwards, and I was so pleased when I realised how to do this. Here's a fresh one. I've obviously parted it off to the right length. I've just touched it around the corners there, so it just makes it look nice and takes the sharp bits off. Rest that in the lathe, in the chuck. Put the washer on the top, one side. It sits very nicely, and then tighten it. That's it. Then I'll get the 3.3mm drill, which is the right size for tapping an M4 hole. Put my spectacles on. I'm going to put the M4 tap in here and do a squeaky bit. And there you have it. Thank you very much. Now on the other end, M5 holes, tapped holes for the bearing support. And there are the ones I've got done so far. They've all got the offset holes, so now I'll do the M5 holes on the other end to support the bearings. Oh, there's another one there. The wonders of a centre drill, because you can see there's a little bit that sticks out where I'd parted it off. There we are, a lovely M5 hole. Just got another 8 or another 7 to do. The next thing to do is to assemble it all. So I've glued in M5 stud sticking out 12mm, and I put a 1mm M5 washer on, then all the lovely grooved bearings, and then an even lovelier M5 dome nut. Look at that. It's just looks so lovely. Can't beat using real metal. That's fabulous. I'll get the others put together and then we can fix them onto the actual bases. Got them on. They look very nice indeed. As I say, that's what's going to guide the Scotch yoke that will control the pitch of the flute. Now the next thing I'm going to do, because I fancy doing it, is to add the 8mm plumbing, and that only comes in a roll. It's very malleable, it's soft and softened copper, some experiment I was doing ages ago. So I've straightened, hopefully I've got enough left, straighten some out, and I'll cut that into the necessary lengths according to the plan. That's very exciting. And then I've got these little 8mm end flow fittings to connect all that up. There we are. The 8mm copper pipe is on, that connects that to there, comes down ready to connect to the motor, or at least look like it does, and then comes down here and disappears through an ewell. And what's in there is a reed switch. Fabulous. Sitting on a thin strip of Veriboard that's insulated either side so it doesn't actually touch the metal at all. And the purpose of that is, as the wheel goes round with all the writing on that controls the pitch, there's a magnet on the back of there that comes round to let the Arduino know where it is. Lovely. I've also added the bit across the bottom, which is going to have little bobbly bits. Nice dome nuts. It's going to have the engraved name on here, so get ready to do that. Oh yeah, and these have arrived. The keyhole fittings are like this. I only had one left before, so I had to order some more. Really good. Very useful. 30mm diameter, so you can rebake them if you need to. Very effective, although the top tip, if you're looking for these, which I spent ages looking for them, reasonably priced, are actually called, these are from Locks Online Limited in the UK, bed fitting capsule 30mm bright steel. That's what they're called. Who would have thought that when they sell them as a way of putting bed heads on and fixing beds together? But that's what they are, and they're so much cheaper to get them these ones rather than other sorts. Here's an interesting problem. I've got to turn all this into the drive system with the big gear in the middle, and the problem always was I had large screws like this coming right through the wood, up through this bit, through the 4 layers actually, 1, 2, 3, 4, 5 layers actually, and this bit holds a bearing, a 30mm diameter bearing, in fact one of those. And then there is a drive shaft that runs from this top bit, let's try and hold this up, well, comes from this top bit down here, has the big gear fixed on, and then ends up on the motor, little stepper motor underneath. And the problem always was getting these two lined up. I thought I was being very clever by having a little bit of movement, a little bit of give, so I could get it all adjusted nicely and then tighten it. But it took ages and was really hit and miss. So, dear friends, a jig. Look at this. Just finished making it. There's a post cut really precisely on the lathe to size, so it fits through the laser cut hole here, which is a clearance hole. This just rests down, slides down on it. It's also got a little pin sticking out the top that goes into the bearing in this top bit, and it is beautiful. And also I've decided to simplify matters by using 2 countersunk screws. It was a bit confusing looking at this, but 2 countersunk screws there and there to hold and clamp this together while it's on the jig, possibly also add some glue, and then that leaves one pivot screw there that's going to go right through into the baseboard, and another one here. That means I can then adjust it to get the gears to mesh properly. Oh, there we are. You can see. That's what I'm talking about. It's taken me a while to do this, to get all the bits and plan it, well, think about it and cut it and everything, but it's one of those things that is going to make this so enjoyable, because now that will not move at all. It can, all these bits can move a little bit, but this will be absolutely vertical. So I'll get on with it. It's exciting. This is working really nicely. I've just tightened them down, the 2 dome nuts, and now I can spray that up. That just lifts off, which proves that it's all lined up nicely. That's a joy. And then just to have to adjust it with 2 screws rather than 3 or 4. Oh, lovely. I'll go ahead and put the other one together. Looking great. Fabulous. And I've just worked out why there seems to be one laser cut lopsided hole here. The reason being that I cunningly designed these 6 spoke bits so that the lathe chuck would grip it properly. So now I can drill a perfect 12mm hole through the centre, and then that little hole will be where I can drip the glue in. It's all coming back to me. Definitely a job for the centre drill. I thought it was worth mentioning this for those of you who want to use those little stepper motors. I took the shaft out of one of them that was broken for some reason, and I used that as a little support jig. So I cut out these, there's one, where's the other one gone so I can show you. Oops, these from 10mm acrylic with the same shape, the right size shape as the drive shaft on the stepper motor. I jam this on and then just turn down, flatten off the end once that's pushed up nice and tight. I've got a bit of 12mm acrylic here that I've already skimmed the end of, or whatever it's called, with the parting off tool. Now I'm going to put a drop of glue, focus, in there, bring them together and let them set, and then use the chuck to pull this off that little brass post, if that makes any sense. And then I've created a nice drive shaft that connects directly to the motor without needing any really complicated linkages and things, and it does work extremely well. So this is what I'm talking about. There's one of the drive shafts. That's the important diameter there, but as you saw, they're all lined up perfectly. That fits on and engages with the spindle on the motor, and there's a little brass pin sticking out the end, which just gluing in very carefully. I hasten to add a couple of plastic or nylon versions of the 13 by 4 by 4 or something or other, whatever you call it, bearings. There's no point in using metal ones. These ones I've had for ages and are absolutely beautiful, and they're going to be hidden away inside, so that's okay. So that's what you end up with. The motor will screw down here to the base, and I can just glue the gear on. I think it's 10mm above this inside bit, and it will be supported beautifully by the bearing within the motor and the bearing within the top bit. This is what I'm talking about, catch-22. I've just realised, of course, that when I've glued that on there, I can't get that in there unless I loosen this, and then that completely defeats the whole idea of having the jig. What does occur to me though is I could cut a slot down here and then just slide this and offer it up. That would solve the problem, or even having this slightly oval would solve the problem. I'll have a little think about it. It's this sort of thing, so many improvements that I'm going to make this so much easier, hopefully, to put together accurately. An executive decision has been made. I'm not going to cut a slot there because it'll show, and I like the way it looks at the moment. What I'm going to do, and have done, is to tap 2 holes. They're M4 holes, well, M3.3 holes, so M4, yeah, taps. Just the steepest angle I sort of get, or the shallowest angle, and then I've got some grub screws, M4 grub screws, which I can then use to attach this finally here when it's in the right position and all adjusted. I'm really pleased with that idea. I think I put 2 of the grub screws in just simply because the plastic is softer than metal and it could, you know, slowly scrape its way around, but I'm sure that 2 will be absolutely fine. So that's very exciting. I've got that done with both of them, so I'll get these sprayed up and the shafts sprayed up, and then get the motor systems together. While the paint on the gears is drying, I'm going to stick on 2 of these beautiful plastic ruby things that just add a certain je ne sais quoi with a new tube of super glue. Right, making sure it's not going to splatter anywhere. Then a little drop. Bit of blue tack, which is fantastic for such jobs. Look at that. Just adds such a nice little touch to it. As you know, if you've watched other videos, I do like to have, along with the brass and the other wooden colours and things, I do like little red features, like the valve handles, knobs, whatever. Just adds something so nice and special. Right, here we are. Right, I've now come to trying to work out on earth to mount this. Now this runs the Scotch yoke, so it's very important that it only rotates and doesn't wibble wobble in any other direction. So the way I've achieved it, having been scouring a wide variety of notes recently that seem to be spread over several sheets and don't make a terribly lot of sense, is I've turned up to 10mm brass shafts and tapped an M4 hole in each end. On the front of the Barometric Prognosticator, there's the biggest bearing I use, which is that one. That supports the mass of this and everything else. Drill a 10mm hole there. Those 5 little holes I've remembered are for glue. That then goes through the wood, and then it goes through one of these funny things, which actually was cut out of the wheel itself. Irony, pathos, I don't know, something or other. Then that goes through there, and then you have a small bearing on the end that it screws into. So when you actually look at the distance between the 2 bearings, it's sort of like 10, 20, 30 mil between them at least, which is great. So that's going to stop any of that sort of movement. Right, I will go and get on with this. So on all these holes are hidden by the engraving, which I haven't yet done, and on top of the engraving in the centre there's also one of these that was sprayed up quite some time ago, so it should be dry, so that'll be nice. It's so nice when you come up with a better way of doing something on lots of different levels. Here's the motor with the shaft shoved onto it. Now of course I can put that through there, and then, oh look at that. That then goes into, I'm getting carried away here, that then pushes into the bearing. I'll screw this down, then I can, look at that, I can just adjust the height, tighten those two grub screws. I'm so pleased, and it looks lovely. I'm absolutely thrilled. They've gone together beautifully, and because of the slight slack in the stepper motor I can check whether the bearing is rubbing or anything, and it's not. That's just fabulous. Beautiful looking things. Next thing, let's get them fitted onto the baseboard. Now the great thing is we don't need that hole or that hole, because that's where the countersunk screws. We just need that hole, which is sort of a pivot point, and this one, which is a bit bigger to allow it to move left and right a bit. I'm so pleased with that. It looks absolutely fabulous, if you don't mind me saying so. It just fits in with the rest of the pipe work. 2 layers, small in the back, large in the front. Just every way you look at it just looks really attractive and interesting, and makes you want to look at it more. I've got these 2 bits to spray up with brass. I've got these 2 bits to spray up with brass, and I was thinking, is there anything else? I remembered the bell, the chiming bell. I was thinking, do I need to open another IKEA clock? Then I remembered I had the steampunk time zone clock, and here we have all the bits. I'm so pleased. Took them apart. In fact, I took it apart to make a bespoke project for someone. That's right, I needed the alarm bit for it, the alarm movement. But there are the 2 bells, and they're like hen's teeth. They're as rare as anything. So, because they're gloss, I'll sand them down with some wet and dry, and then I'll paint them up as well. I spent hours looking for these on the intranet. Nothing, unless you want to buy a special one to replace one on a special clock that costs a special price. But there we go, these will do nicely. You can see the difference. I've gone over this with 400 grade wet and dry, because obviously it's so shiny. I'm not sure the plastic coat, even though it sticks like the proverbials with a shovel, it's asking a lot of it to stick to a gloss varnish surface, so just scratching it over lightly like this will make it really stick well. Oh, by the way, here is the, what is it, Vertig? Oh, I didn't even say. All the other numbers on, what do they call it? Oh, no, it's not Vertig, it's Decad. And after I found the Vertigs, that must be the big clock, I was thinking, well, I did lots of research and found that actually for £8, as this clock cost at the time, the alarm clock, it works out £4 a thing, and it was by far the cheapest I could find them anywhere. So I bought a load of them. Yes, never a dull moment. Thank you so much for watching. Hope it's been useful. Remember to click on subscribe and like and other stuff. Next time, making gears and engravings and all sorts of stuff. Thanks again.